Hello everyone, welcome back to our financial math series. In this video, we will discuss actuarial modeling. In the 811 notes, the chapter is called The Principles of Actuarial Modeling and it is chapter 1 of the financial maths course. So without wasting any more time, let us get started. This chapter gives a solid introduction to modeling, particularly within an actuarial context. It teaches some key principles that are important for understanding actuarial modeling. So key points that are discussed in the chapter include answering the questions on why we use models, how to create them, and their benefits and limitations. We'll also learn about testing the suitability of a model, analyzing the output, and communicating the results of a model. These principles are important in the world of actuarial science as actuaries work with models a lot in practice. So to start off, one fundamental question we must address is, why do we use models? Well, a model is an imitation of a real-world system or process. It allows us to understand and predict the consequences of changes without directly impacting the real world. Let's look at a few examples to illustrate these concepts. We can create models for various activities, such as the economy of a country, the workings of a human heart, or even the future cash flows of a life insurance broker distribution channel. These models help us to simulate and predict the effects of changes in these systems. Imagine we want to predict the impact of a real-world change on these models. It may be too risky, expensive, or slow to try out the change directly. For instance, if we introduce a change without using a model, the consequences could be severe. The economy might go into a recession, a patient's life could be at risk, or an insurance company might face unprofitable premium rates. So this is where actuarial modeling becomes invaluable. A model enables us to investigate the possible consequences of changes before implementing them in the real world. By changing input parameters within the model, we can study the effects and make informed decisions. By incorporating different parameter values such as interest rates, inflation rates, or company-specific factors, we can explore a range of possible outcomes, right? So, what are these input parameters? Let us take a closer look. Suppose we want to buy shares in a company and need to calculate their future price. We can develop a model that relates the price of these shares to various factors. Within this model, we assume certain fixed values for parameters like future interest rates, right? So these parameters are fixed within the model, but we can vary them to obtain different models. For example, assuming a 6% per annum interest rate might give us one value for the share price. However, we cannot be certain that 6% is the correct input. What if interest rates rise to 10% or fall to 3%? Right? So by adjusting the parameters in the model, we can explore different scenarios and answer questions about the potential outcomes. We can even introduce randomness to the parameters by assuming distributions, right? So this allows us to capture the uncertainty and inherent risk in the real world, right? So for instance, let us say we want to determine the expected return on investment for the shares in the company. We could create multiple scenarios, each with different assumptions. One scenario might use conservative estimates, assuming a lower interest rate, moderate growth, and limited risk factors. Another scenario could be more optimistic with higher interest rate, aggressive growth projections, and a higher risk tolerance. Now, you might be wondering how we handle the randomness and uncertainty in these parameters, right? So that's where the probability distributions come into play. Probability distributions allow us to assign probabilities to different values of the parameters rather than fixing them at a single point. By doing this, we can capture the inherent uncertainty in the financial markets and the economy. For instance, we might assume that the future interest rates follow a normal distribution with a certain mean and standard deviation. By incorporating probability distributions, we can perform stochastic modeling. This means that instead of providing a single best guess or best estimate, as they call it like in practice, we generate a range of potential outcomes based on the probabilities assigned to different parameter values. Actuaries use a variety of mathematical and statistical techniques to simulate these scenarios and analyze their impact on the financial projections, right? So through this process, they can gain insights into the potential risks and rewards associated with the different investment decisions. Okay, so yeah, so we can kind of see that actuarial modeling enables us to make more informed decisions by considering a wide range of possibilities and their likelihoods, right? So it helps us to understand the risks involved and make strategies to mitigate those risks, right? So yeah, I hope you now have a better understanding of the principles of actuarial modeling and why we use models, right? Because it's a powerful tool for predicting future financial outcomes and making sound investment choices. So next up in my videos, we'll look at more actuarial modeling and look at how models are used. Okay, so yeah, thank you for watching and stay tuned for more informative videos.